to show you how to turn your trained CNN model into an interactive web app using Streamlit. So if you've been following my channel, you'll remember we previously built an F1 car classification model. Now it's time to deploy that model and make it accessible via a user-friendly web app. Let's get started. Before we dive into the code, let me quickly show you the resources we'll be using today. This is the code from the previous video where we trained F1 car classification CNN model. You can watch that video for full walkthrough of this code. And now we have to save our model by just writing model.save, and here we have to pass the model name and .h5. This .h5 is basically model's extension. And this is the Kaggle dataset that we have used to train the model. This contains images of different F1 cars from various constructors. It has 10 classes, as you can see here, and every class has certain images. And third thing is, this is my GitHub repository. Here you can find full code of making the CNN model. This is the code of training the CNN model, and this is the CNN model that we have trained, .h5 file. You can directly download it from here, or you can build it from scratch. And this code is that we are going to write in today's video. This is the Streamlit code for making web application, and you can directly download it from here or clone the Git repository to use everything of this code. And these are the requirement.txt file, which is the necessary libraries that we have to install. So let's get started with the code. So here is our full code that we have to take a quick walkthrough for making a web application by Streamlit. So the framework that we are using is Streamlit. This is the Python library, which is very easy to use, and basically this is used for general model into web converting. First, I'll walk you through the full Streamlit code, then we'll run the app locally and see how it works. Let's break this down step by step. So here we are importing necessary libraries like Streamlit, PIL, and TensorFlow. Streamlit is, as we know, for building the app, and PIL to handle images, and TensorFlow is to load and predict the model. Load the model and predict our output. Here is the class name list. Here we have to pass every class name that we are expecting from our model. As you can see, here are 10 classes, and we have to pass all these 10 classes here for output. And this is the function preprocess image. What this function do is it take image as input, and then it open the image, resize the image into 224 by 224. Why 224 by 224? Because it is expecting image of 224 by 224 resolution in input that we have passed in our model here. Here you can see the input shape that our model is expecting is 224 by 224. You will get error if you pass any other resolution here. If you are passing let's say 256 here, so you have to pass 256 here also. So make sure not to make mistake and pass correct input shape here. And this is basically converting the image into tensor, 3D or 2D tensor, and here it is normalizing the image, and after that it is returning the numpy array in output. So this is our second function, which is make prediction. So what this function does is it take model and image as input, and then it pass that image into model to predict the class. It is predicting two classes, the first predicted class and the second is second highest probable class. To make sure if first is wrong, then we can take second as our output. So it will return predicted class, second highest class, and prediction probabilities. And so here is our third function, get car info. Here we are passing some additional information about every class in our model. So this is just for fun, I think. And from here our main function is starting. So here we are defining the layout of our app. So this is the title of our app, F1 car image classification app, and this is the subtitle or the subheader which we are going to display on the app. Upload an image to classify it. The app supports the following car brands. Column 1, column 2, these are two columns. Basically this is to make app more visually appealing. These are the classes that our model is going to predict, and this line is for uploading the image. This is the file uploader, and it is expecting only image type in input. And so we'll have to pass JPG, JPEG, and PNG file. Now we have a conditional statement here. If upload file is not none, means if upload file is not empty, then start the process. So here we have a spinner loading and processing the image. This spinner is basically for waiting purpose. Our model is not too fast, it will take some time to predict the class. Till then we'll show this on the screen, and after the prediction we'll show predicted probabilities, car name, and that additional information of the car. So displaying results. Finally, we will display results on Streamlit app, including predicted class, its probabilities, and additional information about the car. Uh, the get car info function, from the get car info function, which is here, and this is the subheader, the car shown in image plus the predicted probability, predicted class actually, and the second most probable plus the second highest probable class, and here's the information about the class and plus additional information. So let's take a look at the app. So how to run this app? To run this app, we have to open the terminal. So open the terminal and write the code cd, and here you have to pass folder path in which your .py file is currently stored. So in my case, my folder path is this cd plus folder path. This is my folder path. So press enter, and then you have to write streamlit run, and then py file name. It means your Python file name. In my case, it is f1 car detection.py. So streamlit run f1 car detection.py and press enter. And this will open the tab in Chrome browser or any of your default browser that you are using. So it's opening and it will take some time. So be patient. So this is our app, which is looking pretty cool, and these are the classes that our app is expecting. These are the classes that we have passed from here, I think. uh, Here, this is the classes and columns we have passed here, and now let's take a look at how this app will work, and try to pass some image, and it will give you output. So let's test the app by uploading an image of an F1 car. So I will try Lotus Formula 1 car first. So I will directly take image from Google and pass that image in this. So I'll take this image, let's say, and we will pass this image directly into our model, and it is loading and processing. It will give you output. Okay, so it is predicting it correctly. Lotus Formula 1 car with 99.95% accuracy, and the second most probable car is Alpha Tauri F1 by 0.05%, which is absolutely correct prediction. And here is the additional information about the car that we have passed here in get car info function, and it is working correctly. So let's try it with two, three more images of different car brands. Let's try it with Aston Martin F1 car. Let's try with this image. Take the image directly into app. Uh, so this is giving us some error. Okay, so our model is only expecting images file, not avif files. So let's take another image which is of image type only. Let's try it with this image. Okay, so it's predicting. Okay, so it's predicting Aston Martin F1 car with 100% accuracy and Mercedes F1 car with 0% accuracy. And here is the additional information. So our CNN model is performing well actually, and it's performing very accurately actually. We are passing images directly from Google in our model, and it is predicting every image correctly. So let's try some more brands like Mercedes F1 or Ferrari. Let's try it with Ferrari. So let's take this image. This image is input. It's loading and processing the image. Okay, it's predicting every image very accurately and correctly. So this is Ferrari, and it's predicting Ferrari F1 car, and providing additional information about Scuderia Ferrari, which is Ferrari Dream basically. So our model is performing well, and it is predicting every image correctly, and our app is looking good. So let's try to open this app in mobile resolution or phone resolution. So yeah, it's looking good in phone resolution also. Okay, it's interactive also, responsive, and yeah, this app is looking pretty cool, right? So that's it for the today's video, guys. You have learned how to create a Streamlit web app for CNN model, run it locally, and share it with the world. You can also deploy this app from Streamlit website by here. You just have to upload this application in GitHub, and then upload that py file in GitHub, and after that you can directly host your website like this on Chrome from streamlit.io website. If you want a full tutorial how to upload or deploy the website on Streamlit, just comment below and I will provide you with full tutorial. And make sure to subscribe and like this video. Thank you for watching, guys, and stay tuned and happy coding.